I'm analyzing the output of the RandomTreesEmbedding function in Sklearn. I'll examine the properties of this output, such as its sparsity and dimensions. I have a dataset that I'm working with. It contains 100 samples and each sample has 5 features. This is my input data for the RandomTreesEmbedding algorithm. My dataset has a simple structure. It's like a spreadsheet with 100 rows, samples, and 5 columns, features. Each row represents a data point, and each column represents a specific characteristic of that data point. I'm using Sklearn's RandomTreesEmbedding, a machine learning tool that transforms data. It works by building multiple random decision trees and using their leaf nodes to create new features. It's like creating a new, lower dimensional representation of the original data. I'm setting up RandomTreesEmbedding. N_estimators equals 10 means I'm using 10 decision trees in the ensemble. Max_depth equals 3 limits each tree's depth to 3 levels. This controls the complexity of the trees. A deeper tree will capture more complex relationships between the features, while a shallower tree will capture simpler relationships. I'm interested in the resulting matrix after RandomTreesEmbedding processes the data. This matrix will be the transformed version of my original dataset. I'm asking myself, will the output be a sparse matrix, mostly zeros? Will it have 100 rows, one for each original data point? Will it have 5 columns, same as the original? I will find out the answers with my analysis. This is a multiple-choice question about the properties of the output from RandomTreesEmbedding. I need to carefully analyze the effect of the chosen parameters on the output's shape and characteristics. I will trace the flow of data. My input data goes into RandomTreesEmbedding with specified parameters, and then I analyze the output matrix of that transformation. I predict this statement is true. RandomTreesEmbedding often creates a sparse matrix because many of the resulting values are 0. Think of it like a mostly empty grid, most cells are blank. This is true. Each row represents one of the 100 samples in your dataset. It's a 1-to-1 correspondence. I believe this statement is false. The number of columns isn't determined by the original number of features, 5. Instead, it depends on the number of leaf nodes in all the random trees created. That's a much larger number. This is false. RandomTreesEmbedding is unsupervised. It ignores the target variable. The output shape is independent of your classes. I'm looking at a dataset with 100 samples and 5 features. Think of samples as individual data points, like different customer profiles, and features as the characteristics of each data point, like age, income, and location. This is a Sklearn function. I use it to transform the data. It creates a lower dimensional representation of the data using a bunch of random decision trees. It's like making a detailed map into a simpler sketch. Here, I'm setting up the RandomTreesEmbedding function. N_estimators means I'm using 10 separate decision trees in this process. Max_depth sets a limit on how deep each tree can grow. It's set to 3. This helps to prevent overfitting. Think of it like building 10 relatively shallow trees. This is what RandomTreesEmbedding gives me after transforming the data. I want to examine its characteristics. The output is a sparse matrix. This means most of the entries in the matrix are zeros. It's a space-saving way to store data with many zeros. It's efficient for large datasets. Because I started with 100 samples in my dataset, the output matrix will have 100 rows. Each row corresponds to one of my original samples. The number of columns, features, isn't equal to my original 5 features. It's actually determined by the number of leaf nodes in my 10 trees, which will be much more than 5, given the max_depth of 3. The dimensionality of the output doesn't depend on how many classes I have in my target variable because RandomTreesEmbedding doesn't use the target variable information at all. It's an unsupervised transformation. I'm using Sklearn's RandomTreesEmbedding, a technique that transforms data using a collection of random decision trees. It's like creating many different views of the data, each highlighting different aspects. My starting point is a dataset. Think of it as a spreadsheet. It has 100 rows, samples, and 5 columns, features. Each row represents a single data point, and each column describes a different characteristic of that point. The dataset's size. 100 samples means I have 100 individual data points to work with, and each data point has 5 characteristics which I want to model using this algorithm. I'm setting up the random trees embedding algorithm. N_estimators equals 10 means I'll use 10 individual decision trees. Max_depth equals 3 limits how deep each of these trees can grow. It's a way to control the complexity and prevent overfitting. After RandomTreesEmbedding processes the data, the result will be a transformed dataset. The question is, what will this new dataset look like? This describes the characteristics of the output from RandomTreesEmbedding. It will be a sparse matrix, mostly zeros, have 100 rows, one for each of the original samples, and more than 5 columns. The exact number depends on the tree's structure. This statement is correct, because RandomTreesEmbedding often results in a lot of zeros in the output matrix. It is best described as a sparse matrix. This is true. The algorithm keeps the original number of samples, so I'll end up with 100 rows in the output matrix. This is incorrect. The number of columns isn't related to the original number of features. It is determined by the structure of the trees, a much higher number than 5. This is also false. RandomTreesEmbedding is unsupervised, meaning it doesn't use class labels in the transformation process. I'm analyzing the output of Sklearn's RandomTreesEmbedding, a technique that transforms data using a set of random decision trees. I'll figure out the shape and characteristics of the output matrix. We have an input dataset. It contains 100 samples, each described by 5 features. This simply restates that the dataset contains 100 data points and each data point has 5 attributes or features to describe it. This is the algorithm I am using to transform my data. I've set the number of trees, n_estimators, to 10 and the maximum depth of each tree, max_depth, to 3. These are hyperparameters for the RandomTreesEmbedding. N_estimators controls how many trees are in the ensemble. Max_depth limits how deep each tree can grow. I need to determine the characteristics of the output matrix produced by RandomTreesEmbedding. Will it be sparse? How many rows and columns will it have? These are the questions I am trying to answer about the output matrix. I'll investigate if the output is a sparse matrix, if it will have 100 rows, one for each sample, and if it has 5 columns, corresponding to input features. This indicates that some of my answers to the questions in row 8 are correct. I'm working with a dataset. It contains 100 samples, each described by 5 features. Think of this as 100 individual data points, each having 5 different characteristics. For example, imagine you're analyzing houses. Each house, sample, might have features like square footage, number of bedrooms, number of bathrooms, age, and price. I'm using a scikit-learn tool called RandomTreesEmbedding to process the dataset. This tool uses multiple random decision trees. N_estimators equals 10 means I'm building 10 separate trees. And max_depth equals 3 means each tree's branching structure is only 3 levels deep. This helps in understanding complex relationships within the data. I already mentioned this, but it's crucial to remember. The dataset has 100 samples and 5 features. This sets the initial parameters I'm working with. This is a repetition of row 2 and reiterates the initial dataset parameters. The output of RandomTreesEmbedding is a matrix. This matrix will represent the transformed version of my dataset. This new representation is more suitable for subsequent analysis or classification using a machine learning model. The size and structure of this matrix are the focus of the quiz. These are the questions I'm trying to answer about the output matrix. Will it be mostly empty values, sparse? Will it have 100 rows, one for each sample? Will it have 5 columns, one for each initial feature? The answers depend on how RandomTreesEmbedding works.